All right, let's look at some of our properties of our logarithms now. Well, let's go back to the day before. Remember to take the log of b base a. All that really means is the base is a, and whatever it equals, that's the exponent we take it to. And when I do that, base to an exponent, that gives me its log right there. So just remember how that works. You know, it's kind of a little ping pong of variables there. So remember, that's your base. This is your exponent, and then that equals the b part of it. The nice part is with logarithms, since they're inverses of exponents, all their properties mirror the rule of exponents. So the exponential properties kind of work the exact same way as our logs. So for example, when we multiply with the same base, what do we do with the exponents? When you multiply, we end up adding the exponents, correct? So same thing. If I multiply with logs, I could break it up and say the log of a plus the log of b. So if I'm multiplying two numbers in a log, I could break it up and say the log of a plus the log of b, or vice versa. If I had the log of some number plus the log of another number, I could put it into one log and multiply those two numbers. Okay, so it works out. We call that a log of a product. Well, guess what? The same thing works with division, right? So when we divide with the same base, what do? We subtract. So the same thing works with logs. If we divide with logs, we can break it up and subtract the two logs, or vice versa. If I have a log of a number minus the log of another number, I could take the log of the first number divided by the second number. And we call that what? Log of a quotient, right? That's our division. And this one's kind of new. It's a little bit different, kind of tricky. Well, if I have a power to a power, we multiply them, correct? Well, if I have a log to a power, what I can do is I can move that power to the front and multiply, just like this. So if I have the log of a power, so that one's kind of tricky. We call that a log of a power, and that's what we use to solve equations. And we'll get into that towards the end of this section, and then you'll see why we do this. Why this one? This is like one of our main ones. We use this a lot to solve when we're looking to solve for a variable in the exponent. So there's our three most important laws of logarithms right there. We got them all. Okay. So in order to solve for an exponent, this is where that 1 comes into play. So most of us could see that x would equal 3 in this case. But let's say I wanted to get the variable out of the exponent, right? Because I want to solve, I want to get it by itself. So in order to do that, I would take the log of both sides. Right? So whatever I do to one side, I have to do to the other side. And then my property is if I take the log of a power, what can I do with the exponent? It comes out front and it gets multiplied. So I take the log of both sides, and now this x will come out front and get multiplied by the log of 5. Okay, so whenever you take a log and it has a number with an exponent, the exponent gets to come out front and get multiplied. That's one of our main properties. We got to get that one down. That's kind of the newest one. And then to solve for x, we would what? Divide by log of 5 on both sides. Right, divide by the log of 5. Whatever I do to one side, I do to the other. And so I'd have x equals the log of 125 divided by the log of 5. What's another way I could write that? I could write that as the log of 125 base 5. And so if I solve for that guy, remember I could type these into the calculator either way, or this one I should be able to do mentally, which I could have done right off the bat. But x would equal 3, right? Because 5 to the third power equals 125. Let's do one where we can't tell what it is right away. So for example, right here, you know, I know it's not going to be 1 and it's not going to be 2, but it's going to be somewhere in between. But how would I do this? Well, to get a variable out of the exponent, we log both sides. We take the log of both sides. Whatever you do to one side, do to the other. And then that allows me to bring the exponent out front to be multiplied, just like we just did. And then I would divide both sides by the log of 5 to get the x by itself. And so then there's two ways to do this. Remember, I could leave it just like that. Or I could say x equals log of 12 base 5. And in this case, we would need our calculator. And then I can type it in either way. I can say log of 12 divided by, whoop, should end my parenthesis, the log of 5. Or like I said, we can go the log of 12 base 5. They should give me the exact same answer, about 1.54. So I'll say x is approximately 1.54. And that was a good estimate. I knew it would be between 1 and 2. And there we go. Okay, same thing with a guy like this. If I have a variable in the exponent, well, in this case, I could probably solve this one mentally, couldn't I? Because 3 to the third power is really 27. And, you know, what plus 2 gives me 3? Well, 1. So I could just do that. So some of these you might be able to do mentally, but otherwise, in order to get it out of the exponent, we would take the log of both sides, correct? So then that would allow me to bring this out front. So I'd have x plus 2 times the log of 3 equals the log of 27. And I put it in parentheses because that whole thing is being multiplied, right? And then I get it to log to the other side, so I divide by log of 3. And I'd have x plus 2 equals either log of 27 divided by the log of 3 or the log of 27 base 3. And then in the end, we would subtract our 2 over. So we'd have x equals the log of 27 base 3 minus 2. And so there's where I would bust out my calculator and solve for that. But we already know the answer, so let's go to the next one. Let's do one where we wouldn't know it. So in this case, like we said, to get a variable out of the exponent, we have to log both sides. That allows me to bring it out front, so we'll fly through this here. Divide by the log of 3 on both sides. And I like to rewrite it as the log of 27 base 3. That's just my convenience. So I'd take my calculator, I'd say the log of, take my calculator, I'd say the log of 274, either divided by the log of 3 or base 3, and then subtract 2. And I get about 3.11. That would be a good answer. So round to the nearest hundredth, about 3.11. And that's it. So basically, anytime to get a variable out of the exponent, you need to take the log of both sides. That's what we're really trying to get through. The last thing is, you don't need to memorize this, but we call this the change of base property. And I kind of did this already once. So if I get something like this, you know, the log of 5 base 3. Let's just take a look. I've already been doing this the whole time, but I could rewrite this as 3 to the x, right? Here's my base to the x equals 5. And then to get the x out of the exponent, I would log both sides. And then that allows me to take my exponent, bring it out front to be multiplied. And then I would divide by log of 3. So basically we're just saying that this is the same as that, which I've been doing already. Okay, so that's kind of the last final property. And I did it a bunch, so hopefully that's already like fresh in your minds that that's one of our properties. And that's how it's written algebraically. And if you notice, it just means they have the same base in the end. And if I look back at this, technically down on the bottom here, what do these have for a base? This is log 5 base 10, right? And log 3 base 10, because those are our, what we call our common logs. Remember the logs when they don't, remember when it's a log and it doesn't show what the base is? It's automatically 10. Okay, we looked at that on our notes the other day. And that's pretty much all of our properties.